Hi friends, welcome back to our series of sessions on energy conservation and management. Today we'll be discussing about boiler systems, different types and their specifications. The boiler is an enclosed vessel that provides a means for combustion heat to be transferred into water until it becomes heated water or steam. The hot water or steam under pressure is then usable for transferring the heat to a process. Water is a useful and cheap medium for transferring heat to a process. When water is boiled into steam, its volume increases to 1600 times, producing a force that is almost as explosive as gunpowder. This causes the boiler to be extremely dangerous equipment that must be treated with utmost care. The process of heating a liquid until it reaches its gaseous state is called evaporation. Heat is transferred from one body to another by means of radiation, which is the transfer of heat from a hot body to a cold body without a conveying medium. Convection, the transfer of heat by a conveying medium such as air or water. And finally, the conduction, transfer of heat by actual physical contact, that is contact from molecule to molecule. Now, if you see the specifications of a boiler, typical boiler specification looks like this. The heating surface is any part of the boiler metal that has hot gases of combustion on one side and water on the other side. Any part of the boiler metal that actually contributes to making steam is heating surface. The amount of heating surface of a boiler is expressed in square meters. The larger the heating surface of a boiler, the more efficient it becomes. The quantity of steam produced is indicated in tons of water evaporated to steam per hour. Maximum continuous rating is the hourly evaporation that can be maintained for 24 hours. F&A means the amount of steam generated from water at 100 degrees centigrade to saturated steam at 100 degrees centigrade. Then we have the Indian Boiler Regulation System. The Indian Boilers Act was enacted to consolidate and amend the law relating to steam boilers. Indian Boilers Regulation, IBR it is popularly called, was created in exercise of the powers conferred by Section 8, 28 and 29 of the Indian Boilers Act. The IBR steam boiler means any closed vessel exceeding 22.75 liters in capacity and which is used excessively for generating steam under pressure and includes any mounting or other fitting attached to such vessel, which is wholly or partly under pressure when the steam is shut off. Next one is IBR steam pipe, means any pipe through which steam passes from a boiler to a prime mover or other user or both. If pressure at which steam passes through such pipes exceeds 3.5 kg force per square centimeter above atmospheric pressure, or such pipe exceeds 254 millimeters in internal diameter and includes in either case any connected fitting of a steam pipe. Then if you see the boiler systems, the boiler system comprises of feed water system, steam system and fuel system. The feed water system provides water to the boiler and regulates it automatically to meet the steam demand. Various valves provided access for maintenance and repair. The steam system collects and controls the steam produced in the boiler. Steam is directed through a piping system to the point of use. Throughout the system, steam pressure is regulated using valves and checked with steam pressure gauges. Then we have the final fuel system, which includes all equipment used to provide fuel to generate the necessary heat. The equipment required in the fuel system depends on the type of fuel used in the system. We see a typical schematic of a boiler room. The water, we have the boiler here and then steam to process. Then we have boiler fuel is coming through a burner to this. And then the water source, which is going through the softeners and to chemical feed going to the boiler, getting escaped as a steam that is going to the process. Fuel that is coming through the burner, going through the thing, and then through the economizer, giving the heat, losing through the exhaust gas. We have a deaerator and pumps which are operating basically the economizer. So this is exactly one way we have the fuel line. And the other way we have the water line. Blue line relates to water line and yellow line relates to the fuel. That's exactly what happens in a boiler room. The water supplied to the boiler that is converted into steam is called feed water. The two sources of feed water are condensate or condensed steam returned from the processes and makeup water, which is a treated raw water which must come from outside the boiler room and plant processes. For higher boiler efficiencies, the feed water is preheated by economizer using the waste heat in the flue gas. Then let's see the types of boilers and their classifications. There are virtually infinite number of boiler designs, but generally they fit into one of two categories. 5-tube boilers, which contain long steel tubes through which the hot gases from a furnace pass around, which the water to be converted to steam circulates. 5-tube boilers typically have a lower initial cost, are more fuel efficient and easier to operate, but they are limited generally to capacities of 25 tons per hour and pressures of 17.5 kg per square centimeter. Then we have water tube boilers, where water in tube boilers, which in the conditions are reversed with the water passing through the tubes and the hot gases passing outside the tubes. These boilers can be of single or multiple drum type. These boilers can be built to any steam capacities and pressures and have higher efficiencies than 5-tube boilers. Then we have the packaged boiler. The packaged boiler is also called because it comes as a complete package. Once delivered to site, it requires only the steam, water pipe to work, fuel supply and electrical connections to be made for it to become operational. Packaged boilers are generally of shell type with fire tube design so as to achieve high heat transfer rates by both radiation and convection. The main features of package type boilers are small combustion space and high heat release rate resulting in faster evaporation, large number of small diameter leading to good convective heat transfer, forced or induced draft fan systems resulting in good combustion efficiency, number of passes resulting in better overall heat transfer and higher thermal efficiency levels compared to other type of boilers. So these boilers are classified based on the number of passes, the number of times the hot combustion gases pass through the boiler. The combustion chamber is taken as the first pass, after which there may be 1, 2, or 3 sets of 5 tubes. The most common boiler of this class is in 3-pass unit with 2 sets of 5 tubes and with exhaust gas exiting through the rear of the boiler. Then we have the Stoker-fired boilers. Stokers are classified according to the method of feeding fuel to the furnace and by the type of grate. The main classifications are chain grate or Traveling-Grate stoker, where the coal is fed into one end of the moving steel chain grate. As grate moves along the length of the furnace, the coal burns before dropping off at the end as ash. Some degree of skill is required, particularly when setting up the grate, air dampers, and baffles to ensure clean combustion, leaving minimum of unburned carbon and ash. The coal-fired hopper runs along the entire coal feed end of the furnace. A coal grate is used to control the rate at which coal is fed into the furnace and to control the thickness of the coal bed and speed of the grate. Coal must be uniform in size, as large lumps will not burn out completely by the time they reach the end of the grate. As the bed thickness decreases from coal feed to rear end, different amounts of air are required, more quantity at coal feed end and less at rear end. Then we have the spreader stroke boiler, which utilize a combination of suspension burning and grate burning. The coal is continuously fed into the furnace above the burning bed of coal. The coal fines are burned in suspension. The larger particles fall to the grate, where they are burned in a thin, fast-burning coal bed. This method of firing provides good flexibility to meet load fluctuations, since ignition is almost instantaneous when firing rate is increased. Hence, the spreader stroker is favored over other types of strokers in many industrial applications. Then we have pulverized fuel boiler. Most coal-fired power station boilers are pulverized coal, and many of the larger industrial water tube boilers also use the pulverized fuel. This technology is well developed, and there are thousands of units around the world, accounting well over 90% of the coal-fired capacity. The coal is ground, or rather pulverized to a fine powder, so that less than 2% is plus 300 micrometer, and 70 to 75% is below 75 microns for bituminous coal. It should be noted that too fine a powder is wasteful of grinding mill power. On the other hand, too coarse a powder does not burn completely in the combustion chamber and results in higher unburnt losses. The pulverized coal is blown with part of the combustion air into the boiler plant through a series of burner nozzles. Secondary and tertiary air may also be added. Combustion takes place at temperatures from 1300 degrees centigrade to 1700 degrees centigrade, depending largely on coal grade. Particle residence time in the boiler is typically 2 to 5 seconds, and the particles must be small enough for complete combustion to have taken place during this time. This system has many advantages, such as ability to fire varying quality of coal, quick responses to changes in load, use of high preheat air temperature, etc. One of the most popular systems for firing pulverized coal is the tangential firing, using 4 burners corner to create a fireball at the center of the furnace, exactly what is shown here. Then we have a fluidized bed combustion boiler. When an evenly distributed air or gas is passed upward through a finely divided bed of solid particles, such as sand supported on a fine mesh, the particles are undisturbed at low velocity. As air velocity is gradually increased, a stage is reached when the individual particles are suspended in the airstream. Further, increase in velocity gives rise to bubble formation, vigorous turbulence, and rapid mixing, and the bed is said to be the fluidized bed. If the sand in a fluidized state is heated to the ignition temperature of the coal, and coal is injected continuously into the bed, the coal will burn rapidly and the bed attains a uniform temperature due to effective mixing. Proper air distribution is vital for maintaining uniform fluidization across the bed. Ash is disposed by dry and wet ash as systems demand. And fluidized bed combustion has significant advantages over conventional firing systems and offers multiple benefits, namely fuel flexibility, reduced emission of noxious pollutants such as SOx and NOx, SO2, SO3, NO2, N2O3 sort of thing, compact boiler design, and higher combustion efficiency. So this is all about the boiler systems, which is for today. So we shall meet again in the next videos to come.